Hello, everyone. Welcome to the workshops, the second workshop of the Request Network Hackathon. I'm super excited to kick it off with David and Stephen. David is the senior blockchain engineer at Request, and Stephen is the senior full stack developer. Like I said, super excited to kick it off. Request is a EVM compatible infra protocol which combines everything Web3 finance. And yeah, these guys are going to walk you through. You have 10 days to build through. The submission window closes by the end of the month. So you better put your hacker hats on. Feel free to reach out to those guys anywhere you're stuck. And if you want, feel free to also revisit the workshops if you feel stuck anywhere. But yeah, with that, I'll not take a lot of time and I'll pass it to David and Stephen. Yeah, guys, on to you.
Sure. So the workshop that we had yesterday was meant to be like an introduction to some of the newest building blocks that we've been building, including our invoicing template, as well as the underlying web components that can be reused for building like an invoice dashboard or a form for creating requests. But we recognize that this is just that those are kind of in their infancy. They support the basic payment type of an ERC20 request, and they support a few select chains. But we thought that this workshop could dive a little bit deeper into the protocol to talk a little bit more about other payment mechanisms that our protocol supports. And so from the previous workshop, you're probably already familiar that when you create a request, you define the payment network. I could go through that real quickly to show what I'm talking about. Maybe you're not familiar with that, so I could talk about that more deeply. The templates take care of most of that for you, but if you're interacting with our SDK directly instead of going through the templates, there's a little bit more involved in setting up the creation and payment of a request. And so if you really want to learn how that works, you can go to the quick start page, quick start browser in our documentation. It shows you all of the different steps from creating a request, paying a request, and then detecting a payment and retrieving a user's requests. All of that is in there. And so I'll just dive right in. In order to create a request, you're going to have to create an Ethers v5 provider, or possibly a WAGMI or VM wallet client. It's also possible to create a request using those. But it's just worth noting that when you actually get to the payment part, for the payment, we do actually require an Ethers v5 provider or some sort of shim to make your provider look like Ethers v5. And we have code snippets to show how to do that. So once you have your provider, you can go down to the next part where we create the Web3 signature provider. This is the part of our protocol, the part of our SDK that will sign things or prompt you to sign things when a request is created. And so there's the Web3 signature provider. We also have other, like an Ethereum private key provider that allows you to just inject the actual private key directly into the SDK for that's more for like back-end sort of usage. The Web3 signature provider is more useful on the front end. So you would create that by just passing the provider into it. And then the next step is that you would want to construct your request network instance. In order to do that, you would import the request network from the request client JS library. You would set the base URL to one of our existing gateways. We have two different gateways over here listed in the request node gateways section. We've got the Gnosis gateway at gnosis.gateway.request.network. Oops, that's not what I meant to do. Go back. And then we also have the Sepolia gateway if you're creating test requests. Jumping back, we can see that after we import the request network and set the base URL, we also pass in the signature provider so that the front end is able to prompt the user to sign things when it comes time to actually create the request. The next step in the process, let me see if I can get this all on screen at the same time. Well, no, it'll be too small. You have to set up a few input parameters for creating a request. The basic info of a request is all in this request info object. It's going to have the currency that you're transacting in, or that you expect to transact in. That's going to have the type. In this case, we set it to ERC20. The value, in this case, it gets set to the smart contract address, and the network. In this case, we're setting it to Sepolia. We set the expected amount, and it's best to specify this as a string because technically you can use a number, but numbers have the limitation where there's a maximum value that can be specified with a number, and at that point you'd have to switch over to a string. And since Ethereum or EVM compatible digits usually have like the 18 zeros after it, you reach that maximum integer point pretty quickly. So it's best to specify this as a string. We also set the payee, information about the payee. We're basically saying that it is an Ethereum address, and we pass in that address as the payee identity value. We can see that it's set up here. We also have the option to set a payer address. The purpose for this is to have a notification in the protocol itself so that the payer is notified when a new request comes in. This is optional because technically, if you set it to null or undefined, then anybody can pay that request. It's possible to just set that as undefined. You also set a timestamp, and you can just we have a utility for grabbing the current timestamp in seconds. And that's just the basic request info there. Outside of the request info, you also set the payment network, and we're going to be spending a lot more time talking about the payment network later on, but I'll gloss over it for now and come back to it. The payment network basically is how you specify the payment type and other details related to how the payment should be executed. We also have the ability to set content data. This is an arbitrary data field where you can put anything in here, whatever is relevant to your application. In this case, I've done a very simple one with a reason and a due date. However, we have a RNF invoice format that we encourage all of our builders to use because it specifies many of the different fields that an invoicing application would typically need, such as, well, if you look at our invoicing template, you'll see a lot of the fields that it provides, mostly around specifying details about the payee, details about the payer, the due date, and the currency and the payment chain and all that sort of stuff. And other stuff like labels. You can add labels, you can add a memo, you can have line items, you can have taxes, discounts, unit prices. All of that is built into the invoice format. And the final thing that you need to add here is the signer. This defines which of the two identities is involved, either the payee or the payer, which one of them is actually signing to create the request. So this is a required field. So once you've input all of that information, you can then call create request, which will pass you back a request object that represents the request in memory on the machine or in the browser that you're using. You would then have to call wait for confirmation to actually complete the creation of that request. The wait for confirmation step is what actually sends the data to IPFS, waits for it to be persisted, and then takes the content addressable ID, the CID, from that IPFS document and puts that into a smart contract on chain. The chain that it gets stored in depends on the gateway that you're using. If you're using the Sepolia gateway, the hash will be on Sepolia. If you're using the Gnosis gateway, then the hash would be on Gnosis. And the difference there is like Gnosis is designed to be around forever, whereas Sepolia obviously is a test net and might not exist forever. And then after all of those two things are persisted, the last step is we wait for the indexer, the subgraph that is watching this smart contract. We wait for it to index the on-chain event that gets emitted. And once all three of those things are completed, this function will return and say that the request is fully formed, fully completed. We have a code sandbox that shows how this process works. And I think I maybe don't have that one open. That's okay. We'll show it in the next step. I have a code sandbox for the pay request as well that I can show. So actually, yeah, let's take a break real quick. Well, this is the code sandbox that I was just referencing. I'm going to blow up the text a little bit so we can see better. We're going to see on the page.tsx, there's a function here called create request. And we can see all of the things that I just described, where we create the Web3 signature provider, we create the request client, we specify the creation parameters, and then finally we call the create request function and the wait for confirmation. All of that can be seen over on the right here. If I just disconnect, I connect my wallet. In this case, I choose MetaMask. I'm going to choose Sepolia as the chain that I'm persisting on. The amount, in this case, I'll just choose 0.1. The currency that I'm selecting is just this faucet token that exists on Sepolia. You can mint an infinite number of them if you just go to the contract address. There's like a mint function. All the rest of the fields, I'm just going to leave blank because they're optional. And I'm going to submit this. And we can see that a MetaMask prompt pops up and allows me to sign the request. We can see the contents right here. I'm going to sign that. And we can see there's a little status down right here that it's currently persisting on chain. The request state is pending. The contents of the request can be seen right here. And we can see that the request was just confirmed and that the request state changed to created. That means that the three steps that I described earlier, the IPFS, on-chain, and indexing all completed successfully. So that's the creation of the request. The next part is, oh, I jumped. Where did it go? Okay, the next step is that you would want to be able to pay that request. And so similar to what I described earlier, paying a request also requires you to have a request network instance. And the reason that I'm duplicating this is because typically the payment would happen on a different app screen, from a different user. So you just have to make sure that you create a request network instance for that user as well. You would connect it to the base URL, but you don't need the Web3 signature provider in this case, because that's only required for creating of requests. Okay, so using this request network instance, you're going to retrieve the request ID. Presumably, the user who wants to pay has been passed the request ID somehow, or maybe they looked up all of the requests that were sent to them by identity. So if the creator specified the payer address, then the payer would be able to look up that request by identity. And so they get a reference to the request. Once they have that, they are able to create an Ethers v5 provider again, similar to before. And they can go through a few steps to make sure that they are able to pay the request before actually submitting the transaction on chain. The first one is that they would have to check that they have sufficient funds. This utility function that we provide has sufficient funds, is going to check that the ERC20 balance is sufficient, as well as the native token balance is sufficient, both to cover the gas cost as well as the native token cost, if there is any. The next step, in the case of ERC20 requests, you would have to check that there is sufficient approval, that the ERC20 fee proxy contract that our protocol provides, making sure that that contract has the sufficient approval to pull the funds out of the end user's account, the payer's account. So we have this has ERC20 approval convenience function that you can call. And if the approval is not sufficient, we also have this approve ERC20 convenience function that you can call that will prompt the user to grant the sufficient approval. And you're going to want to wait for, you're going to want to configure it with two block confirmations. I think it's actually just the first block where it's mined or validated, I should say, and then the second block after it that's confirms that the block was not uncled or reorged away. So once you have the approval, then finally you can call the pay request function. And this convenience function is going to just take in the request data that you pass it, and it's going to figure out exactly which payment network smart contract that you're actually needs to get called in order to fulfill that request. And so similar to before, you're going to wait for 2 block confirmations before counting that as completed. I should mention the 2 block confirmation thing is only valid for like Ethereum chains or slower chains. Some of the faster ones that have a faster block time, like Polygon or Gnosis or many of the L2s, they might have a higher risk of reorgs, and so you might want to wait for additional block confirmations in those cases. And so finally, we have the ability to query the balance of a request. And so we use that mechanism to figure out when a request has been paid. You basically pull the balance amount by refreshing the request using this refresh function. And when the balance when the balance changes, either when it's equal to the expected amount or greater than the expected amount, that's when you consider that the request has been fully paid. So I can show you an example of this in our quick start here. I had just created that request earlier, you recall. And so what I can do is I can switch to the payment chain, which it appears that I'm already on. Yes, I'm already on Sepolia. And then it prompts me to approve. It's going to check if I have sufficient funds. And oof. Oh no, my demo failed. I hate it when this happens. That is unfortunate. Okay. Maybe I can skip that step. Let me just hack it real quick. I'm pretty sure I already have approval. So let me see if I can make it so that I can just click the Pay Now button. Pay the request. I know. So I've got handle approve. I'm just going to replace with handle pay. Is that what it's called? My apologies, everyone. I'm just hacking this to try and get it to work, and I forgot the name of my function. So there's handle submit. I think this is handle create, handle approve, approve. It is called handle pay. My apologies. Okay, so I think that is just reloaded here. I'm going to connect up my wallet. I'm still on Sepolia. I think I need to create the request again. Yes, I do. Submit. I'm going to sign that. So it's persisting again. The request state is pending. In a moment, it should change to created. Excellent. And now when I click the approve button, it should actually just start the payment. Stefan, do you see what I'm doing wrong?
Yeah, I'm looking at it, but I'm gonna check it on my end.
Unfortunately, this is not working. But what is supposed to happen is after you click the pay button, it's going to bring up the MetaMask prompt again that prompts you to actually fulfill the request. The to field of the payment is actually going to be the ERC20 fee proxy contract that you just granted approval to. It's going to show you the amount that you expect to pay. It's going to show the currency, and then it's going to have like a sign or approve. Is it approve? Or maybe it's send. I can't remember the button name that MetaMask shows you, but it's like when you sign a transaction normally, when you send a function call, that's what it'll show you. And I would have the ability to just send that, and the funds would automatically be processed through the appropriate smart contract. I do have some videos of this working. So if you want to see it in action, you can go to the Quick Start browser page of our documentation, and you can watch through the video of me doing basically what I just showed you. I'm going to move on to the next stage just in the interest of time. We also have the ability to retrieve a user's requests. I kind of glossed over this earlier, but you would need to create a request network instance, assign it to the gateway that it's connected to, and then you would just call something like request client.from identity and pass in the identity address that you want to look up all the requests for. So in this example, I'm giving it this address, and what I can do is I can then I receive this list of request objects, and in order to actually read the data in a more easily human readable form, what I can do is call request.getData on each one of them, and that's what this map is doing. And so then I have this array of request datas that you can view. This code sandbox shown at the bottom here is an example of that working. We can see that for this user, here's a very simple table showing all of the different requests that they've created. It seems like they're purchasing a lot of pizza, and the balance for all of these is 0 because I haven't paid any of them. So that is the quick rundown of like the basic way of interacting with the SDK. And my hope for the rest of this presentation is to talk a little bit about some of the more advanced payment types that we support. ERC20 payments are the very basic version, but we also support the ability to do a native payment, meaning that we're transacting in the native token of whatever chain we're on. On Ethereum, this would be Ether. On Polygon, this would be Matic. On a lot of different L2s, this would also be Ether. But you get the gist. It's the native token of the chain. So we in order to process those native payments, we have to use a different smart contract when the payments gets processed. But it looks very similar to the ERC20 fee proxy that I just that the basic Quick Start uses. In the Ethereum with a fee case, when you are creating the request, let me pull up a better example actually. Yeah, this is what I want to show. Oops, I just want that to go away. Okay, so this code snippet looks very similar to the one that we were just looking at. The only exception is that this one is using an Ethereum private key signature provider instead of a Web3 signature provider. That's because this one's back-end code, whereas the other one would be front-end code. But it works the same either way. The main difference when creating a native payment is in the request create parameters that you would pass when creating the request. In the payment network field, the first thing that you'd have to change is this ID. Instead of giving it the ERC20 fee proxy contract, you would give it the ETH fee proxy contract. So that's a different identifier. The next thing that you would do is you would have to adjust the currency that you're passing in. Previously, this was set to an ERC20, and the value was the address of the token that you're sending. In this case, for a native payment, you would put in ETH, and this is true even if you're on some other chain that doesn't technically use Ether for its native token. We still use the ETH modifier identifier. And then for the value here, you would just put in the string ETH. And with those three things changed, the ETH fee proxy contract, ETH, and ETH right here, everything else gets processed the exact same way. The expected amount would now be interpreted as the native token amount. And I think typically native tokens have 18 decimals. So you would have 18 zeros at the end of whatever number that is. And then you just call create request, wait for confirmation the same way that you would in the previous example. We can see this in action real quick here. npm run create native, I think it's going to be. So what I'm expecting here is that it's currently persisting in IPFS, putting the CID on chain, and then waiting for that to be indexed in our subgraph. Once all three of those things are complete, it's going to print out the JSON of the created request. The same thing that we saw in the quick start a moment ago, but in this case, it's all squished together. And so we see we created it with the currency ETH on Sepolia. We can see that the ID of the payment network is PN ETH fee proxy contract right here. So that's how you create a native request. We have other request types that we also support. There's the ability to create conversion requests. So this what I'm showing on screen right now is the specification of the conversion to ERC20 with fee proxy. Sometimes also just known as the ERC20 conversion proxy. This one is very similar to the ERC20 fee proxy, with the exception that it actually does it has a price feed that it reads from at the moment of payment. And what that allows you to do is the invoice that is created can actually be denominated in something other than cryptocurrency. It could be cryptocurrency, but it could be more commonly it's like a fiat currency like USD or perhaps euros or something like that. It all depends on the accounting system that it's eventually going to be plugged into. Typically, invoices are denominated in whichever currency the accounting system uses. But what this conversion proxy allows for is that the settlement, the actual payment that is associated with that invoice, can be executed in cryptocurrency. And by using the price feed at the moment of payment, it ensures that regardless of price fluctuations in the settlement currency, the value specified on the invoice is still sent. In more concrete terms, what you could do is your invoice could be in USD, but the actual settlement could be in USDC. And even if at the exact moment of payment, USDC is worth $1.01 instead of $1 flat, it guarantees that the recipient still receives exactly, say, $500 worth of USDC at the moment of payment, because their invoice says $500 on it. The way that you would call this, I'm kind of showing the parameter focus in on right now is the max rate time span. Basically, you would put in the the list of you would put in, sorry, let me go back. You put in the list of accepted tokens, the tokens that are acceptable, and then you would also put in the max rate time span. So this will determine which currencies are allowed, and then the max rate time span specifies how long the latest price feed reading should be valid for. And using those two things, it's able to do a call to Chainlink at the moment of payment. It's able to convert from the USD amount specified in the invoice over to the USDC value at the moment of payment. In practice, I don't have an example to actually show you, but in practice, you would be editing the values that go into the payment network field of the creation of the request. Oh, this is not what I want to look at. I want to look at right here in the payment network, the parameters that you would be passing in instead of the, or in addition to the ones that you see here, you would also be passing in like the max rate time span and the accepted tokens, something along those lines. Similar to the conversion for ERC20 requests, we also support conversion for native requests. So it's almost the exact same thing, except that it's for Ethereum or Matic or whatever the native token on the chain is. And one that I glossed over earlier is declarative payments. This one is a little bit different. All of the payment types that I described so far involve doing things on chain. They actually have smart contracts that process the payments, and they emit events that are then indexed by our subgraphs. All of that is really great, and I encourage you to use it when you can. But if for whatever reason the currency or the chain that you want to transact in is not supported by one of our existing payment smart contracts, what you can fall back to is using the declarative payment type. And this one is different because it involves writing data to IPFS in order to establish a consensus between the payee and the payer that the payment has been completed. What this allows for is the user flow would look like somebody is trying to pay a request on some chain that we don't currently support. Say it's on Solana, for example. You want to do a payment on Solana. The payer would use the native mechanisms on Solana for sending the payment. Either they would transfer the native SOL tokens, or they would transfer the I think they call it SPL20s over to the recipient address, and then what they would do is they would call request dot declare payment sent. And once they have done that, that creates an entry into the IPFS document showing that the payer has declared the payment was sent. And then the payee can do a similar thing. They call request.declare payment received, which also writes something into IPFS. And once both parties agree that the payment was completed, the protocol considers that the payment was completed forevermore after that. And every time that you query the balance of that request, it's going to show up as being yes, yeah, I believe the balance calculation will return as the full amount. It's also important to note that all of the other payment types that I've described so far today, the ERC20, the native, the ERC20 conversion, and the native conversion, all of those inherit from the declarative payment network. So if at any point the underlying payment smart contract fails, or you're not able to access it for some reason, you can always fall back to using a declarative payment to show that the payment was completed. Declarative payments can also be used for fiat payments if you so chose. So if you wanted to use a traditional finance Web 2.0 bank sort of thing to process the payment, you can do so, and you can just use a declarative payment to show that in the protocol. There's a few more payment types that I'd love to talk about briefly. So what I'm going to do is I'm going to go into the guides that we have right here on this page. Now, unfortunately, our documentation on a lot of these is not fully fleshed out yet, but I will say that there's other payment types that exist in the protocol, and if you have any questions about anything in particular, I would be happy to answer it in either our Discord or in our GitHub discussions page. I think that I can share some links to those in a little bit. But in addition to the payment types I've described, we also support batch payments. Batch payment is where we take any of the four ERC20 native, ERC20 conversion, or native conversion, any of those four different types. You can pay multiple requests in a single transaction using our batch payment contract. There's also swap to pay. That's the idea that at the moment of payment, it actually executes a swap right before. So that way the payer can send one cryptocurrency, but then the payee can receive a different cryptocurrency, like the actual settlement currency. And the cool thing about this is that we can actually take swap to pay and combine it with our conversion feature so that the invoice can still be denominated in USD. The payer can send USDT or DAI, and the payee can receive USDC as a simple example. So that's what our swap to conversion payment network enables. We also have the ability to do escrow requests. This is where the funds actually get deposited into an escrow smart contract by the payer, and the funds will stay there for some amount of time until, say, for instance, it's for a work agreement, and some amount of work needs to be done before the payment is released to the payee. The escrow smart contract involves some consensus between the payer and the payee to decide when that is, but once both parties have agreed that the work is completed, the funds are then released to the payee. We also have it's not listed here, but we have the ability to do a what we call a transferable receivable request, or more colloquially, you can call it a request NFT. What this allows you to do is to take an invoice and mint it as an NFT, and then take that NFT and sell it to someone else. What this enables is kind of like a invoice financing or invoice factoring sort of feature. The invoice could be sold to the lender for a fraction of the total value of the invoice, say 80 or 90%. And then when the invoice gets paid by the payer, the full 100% value of the invoice gets transferred to the lender. And so the lender makes, whatever the difference between the two percentages that it purchased the NFT for, that's how much profit they would make on that. We also have the ability to do streaming requests. This one does have a little bit more details around it in the docs. This is where we are able to use an ERC777 super token from Superfluid to fulfill a request. And the way that you would do that is it actually involves two different requests, both fulfilled by the same series both fulfilled by the same stream. You would issue the first request in the series, and that defines the expected flow rate, the expected start date. And from those two, it can derive with the expected flow rate and the expected start date and the expected amount, it can derive the expected end date. And so all of those parameters define how the stream should operate. And there can be additional requests after that, after the initial one, that define additional recurrence amounts. If you have more questions about streaming requests, feel free to reach out to me in the Discord or in the GitHub discussions. I think that probably wraps up everything I want to say today. Obviously, there are many different payment types available in Request Network. And I encourage you, if you are interested in experimenting with one of these more advanced payment types, please feel free to reach out to us. We recognize that our documentation on that front is not quite where we'd like it to be, but we're happy to help in any way that we can if you reach out to us.
Thanks a lot, David. I hope that was helpful for the devs building in this hackathon. And yeah, like I said, 10 more days until the submission window closes. Feel free to go through the docs. Feel free to also revisit this workshop anywhere, just play it, rewind it as per your convenience. And do join the Request Network Discord, and, feel free to maybe find other developers to build with, or put your questions over there, connect with the request team, or yeah, just like jam over your ideas. Yeah, with that, thanks a lot, David and Stephen. That was very interesting. And yeah, anything else that you maybe want to throw light for the developers on? Any expectations from this hackathon that you want to highlight?
We covered it a little bit yesterday, but there's a bunch of ideas that you can grab from the DoraHacks website here. There's some ideas on the ideas tab, and I think we also put some ideas. Where did we put it? On the bounties page, maybe? Yeah. On the bounties page, we've got a few different ideas on ways to use our different payment networks in interesting ways. We can see that if you're building an invoicing app, you could use probably any of those different payment networks that I just described. So lots of cool ideas to build, and I'm happy to help in any way I can.
Thanks a lot, David. And yeah, good luck everyone who's building in this hackathon. And we'll see you in the next workshop. Bye-bye.
Thanks, everyone. Bye.
Thank you. Bye.